Hi everyone, I'm Sumit from 𝗏𝗏𝗃𝗃𝗹𝗏. Welcome back to 𝗏𝗏𝗃𝗃𝗹𝗏's YouTube channel. Today we are going to solve problems from the previous Codechef contest, which is Starters 155. So let's begin with the first problem. Now coming to the first problem, Chef and Parole. So the problem statement says that Chef must spend at least 7 days in prison to be released on parole. What do you mean by parole? Parole is nothing but a permission given to a prisoner to be released early based on some condition. Okay, now the condition here is chef must spend at least 7 days in prison to be released from the prison. Now you have been given the number of days he spent in the prison. You'll be printing yes if will be released. Otherwise, you'll be printing no. Now if you see the input format, the first and only line of input consists of an integer x, which denotes the number of days spent by a chef in the prison. Now output format, you'll be printing yes if chef will be released, otherwise you'll be printing no. Now coming to the constraints of x is minimum 1 and maximum 30 days. If you see the sample input 1, the number of days spent by a chef in the prison are 5. Now he need to spend 7 days in a prison, but he spent only 5 days. That means he will not be released from the prison. So you will be printing no. Now coming to the next sample input, the number of days spent by chef was 12, which is greater than 7. So he will be released from the prison on a parole. So you'll be printing yes. Okay. Let's start solving this. So you'll be taking input, let's say x, which is number of days spent by a chef in prison. Okay, so if x is less than 7, that means the number of days spent by a chef in prison are less than 7. He will not be released, so you'll be printing no. In the else condition, what will you print? He will be released, so you'll be printing yes. That's it. Now let's run this and see is it working or not. Okay, so we got the expected output, which is no. Let's submit this and see. Done. Correct answer. So this is about the first problem. Now coming to the second problem, which is rectangle. Now the problem statement is chef loves to draw rectangles and he wants to draw one of the rectangle with the largest area possible. But the problem here is his pen has only enough ink left to draw a total of n unit length of line. Now we need to help him to find the largest area of rectangle which he can draw if he wants to draw rectangles with integral sides only. Now they also mention one point here, which is note that he does not need to finish all the ink which was present in his pen. Now what do you mean by this point? There is no requirement that he should be completing all the ink that was present in his pen, not required. After drawing the rectangle, some ink can be present in his pen. Okay, now coming to the input format, the first line of input will contain a single integer t, denoting the number of test cases. And each test case consists of a single integer n after every new line, denoting the ink left in his pen. Now coming to the output format, what we need to print is, for each test case, we need to output on a new line, which is the area of the largest rectangle chef can draw. Now coming to the constraints, that there will be 100 number of test cases at max. The value of n can at max go till 10 power 3. Okay. Now coming to the sample input one, what he's saying is there are 3 test cases present. And now coming to the first value of n, we'll be able to print a rectangle of maximum area, which is 4. Now I hope you know how to calculate the area of rectangle. Simple, length into breadth will give you the area. Now the next input is 1. That means there is only 1 unit of ink present in the pen. So is it possible to draw a rectangle? No, it's not possible. So we'll be printing 0 as the area of the rectangle. Now for 15 we got 12. How do we got 12? Now let's say you have a box like this. Can I say this as a rectangle? This is a rectangle, right? Now, let's say this is A, this is B, this is C, and this is D. Now, in a rectangle, the value of A should be equal to B, and the value of C should be equal to D. Only then we can consider it as a rectangle. Now, we cannot consider this as a rectangle if the value of A is equal to B, and if the value of C is not equal to D. Or else we cannot consider this as a rectangle if the value of A is not equal to B, and if the value of C is equal to D. Also, we can say it as if A is not equal to B and if C is not equal to D. Also, we cannot consider it as a rectangle. Okay, now this is simple math logic that we have found over here. Now coming to this point, what I'll be doing is we need to find the total amount of ink taken to draw a rectangle. First, we will see how to figure out the total number of or total unit of ink completed to draw a rectangle. We'll try to figure out the maximum rectangle later. But as of now, let's try to find the total amount of ink taken to draw any rectangle. Now, as the values of A and B are equal, can I replace this B with A? Yes. Similarly, I'll replace this D with C. Now, how can we calculate the amount of ink taken to draw this rectangle? Can I say that summation of this and this and summation of this and this? That means it is nothing but A plus A plus C plus C. Can I write this as 2 into A plus 2 into C? If this is less than or equal to n, that means the amount of ink present in his pen, I can say that he can draw this rectangle. Now after drawing the rectangle, okay, the first step we came to know how to calculate the total amount of ink taken to draw any rectangle. After drawing a rectangle, how do we need to find the area of the rectangle? Simple, length into breadth, which is A into C, will give you the area of the rectangle. Okay, now we need to find what? We need to find the maximum area that he can get by drawing a rectangle, which will be present in this range. Okay, now let's say you have drawn a rectangle which is of length 1 and breadth 1. Now what is the area of this rectangle? 1 into 1, which is 1. So yeah, now coming to the area, just a second. Now coming to the area, what is the area of this rectangle? Area is 1. And what is the amount of ink taken to draw this rectangle? I'll replace the value of A as 1 and I'll replace the value of C as 1 in this formula. Okay, so the amount of ink consumed over here will be 2 into 1 plus 2 into 1, which is equal to 4, which is less than or equal to 8. Let's consider for the first test case and let's see how are we getting 4 as output for an input 8. Okay. Okay. So this is one of the valid rectangle that we can draw. Now after getting the area, we need to maximize this. We need to try to maximize this area. Now how to maximize this area? Now what I'll be doing is instead of taking a area of length 1, I'll be taking taking a rectangle of length 2. Okay, and breadth will be 1. So this is a rectangle which is of length 2 and breadth 1. Now how can we find the amount of ink consumed to draw this rectangle? I'll be replacing A with 2 and C with 1. So yeah, the amount of ink consumed to draw this rectangle will be 2 into 2 plus 2 into 1, which is equal to 4 plus 2, 6, which is again less than or equal to 8. That means he can draw a rectangle of length 2 and breadth 1 with the ink present in his pen because it is less than or equal to 8. What is the area of this rectangle now? 2 into 1, which is greater than the previous rectangle that we have drawn. Okay, fine. Let's see for another example. Now what I will be doing over here is I'll be drawing one more rectangle. Let me draw that rectangle over here. Again, I'll be increasing the length of the rectangle. This time I'll be drawing the rectangle of length 3 and breadth 1 itself. Now, what is the area of this rectangle? 3 into 1, which is 3. Okay, now the area of this rectangle is 3. What is the amount of ink taken to draw this rectangle? Let's replace the values of A with 3 and C with 1. So which is equal to 2 into 3 plus 2 into 1, which is equal to 6 plus 2, 8, which is again less than or equal to 8. So even this is also a valid rectangle that we can draw from the ink present in his pen. Okay, now what is the area? Which is 3. Now, one question, if I draw a rectangle of length greater than 3, will it work? Is it possible? Okay, let's see. So this is a rectangle of length 4 and breadth 1. What is the area of it? Which is 4 into 1, which is obviously greater than the previous rectangle that we have drawn. But is it possible to draw this rectangle with the ink present in my pen? Let's calculate. 2 into 4 plus 2 into 1, which is equal to 10, which is not less than or equal to 10. This fails. So we cannot draw this rectangle. Okay. Now, what I did here, I go on increase the length of the rectangle. But have we tried of increasing the breadth of the rectangle? Not yet. So let's see how to increase the breadth of the rectangle. So keep this formula in mind. So this will be the hint to solve this problem. Okay. Now, what I'll be doing is I'll be increasing the breadth now. Here if I increase, not here, let's say here if I increase the breadth, it will be 2, length will be 2, and I'll be increasing the breadth by 2. Okay, so this is 2, this is 2, this is 2. Now we will check what is the area of this rectangle. What is the area of this rectangle? 2 into 2, which is 4. Okay, so the area of this rectangle is 4. Now we'll need to calculate the amount of ink taken to draw this rectangle, which is equal to 2 into 2 plus 2 into 2. Simple. I replace the value of A with 2 and I replace the value of C with 2. So this will be 8 now, which is again less than or equal to 8. So we can draw this rectangle. Now what is the maximum area that we got? 4. Now let's see how to solve this problem. So first let's take the input of the test cases according to the sample input that we have given. So C in D while T minus minus. Now we'll be taking the units of ink present in the pen. So C in N, then we'll be taking one answer variable which is initially 0. That is the area of the rectangle that he can draw initially is 0. Now what I'll be doing is I'll be calculating the amount of ink used to draw any rectangle. So what is the value that I'll be taking is I'll be trying all the possibilities of the length and of the breadth. So we have started the rectangle of length 1 and breadth 1. Then what we did, we kept the breadth as 1 and we go on increased the length of the rectangle, and we are able to find the area if it is less than or equal to n. So here what I'll be doing is I'll be taking two for loops where initially my value of I will be starting from 1. I go still less than or equal to n I plus plus. Now this is for length. Now we need to increase the breadth every time. So j should start from 1, j less than or equal to n, j plus plus. Now how can I say that we can draw this kind of rectangle? What is the formula that we have came up with? Simple. It is 2 into I plus 2 into j should be less than or equal to the amount of ink present in my pen. If this is a valid rectangle that we can draw, how will you get the maximum length? Not maximum length, maximum area. So answer will be equal to maximum of answer that you have calculated and the current answer, which is nothing but the current area, which is nothing but I into j, which is nothing but length into breadth. So you'll always update the value of answer if it is a valid rectangle. After trying it for all the length and breadth, we'll be getting the maximum valid rectangle, maximum area of the valid rectangle. So I'll simply print the value of answer. We'll be printing the answer in new line every time. So let's run it and see, are we getting the expected output, which is 4, 0 and 12. Okay, let's submit this. Yeah, so we got the correct answer. Now coming to the third problem, GCD to 1, easy. So as of now, ignore this statement. This is not required now. Let's start with the problem statement directly. So we need to construct a matrix A of size n into m such that the GCD of every row and column will be equal to 1. And elements of matrices should be starting from 2 to 10 power 9. That means 1 should not be present in the matrix. Okay. If there are multiple answers possible, you can print any of the possible answer. Okay, so now coming to the input format, the first line of input will be containing a single integer t, which denotes the number of test cases. And each test case contains or consists of single line of input. So the first line of each test case contains two space separated integers n and m, which represents the number of rows and number of columns in the matrix respectively. Now what you need to print in the output is we need to print the matrix of size n into m, which follows this particular rule. GCD of every row and column should be 1. Now let's see what is a GCD of 2 and 3. What is a GCD of 2 and 3? What are the divisors of 2? 1, 2. That's it. What about 3? 1 and 3. Now what is the greatest common divisor? 1. That's what we want. Now next, coming to 3 and 4. What is a GCD of 3 and 4? The common divisors here is 1 and 3, and here is 1, 4, 2, 2. What is the GCD from here? 1 again. Again, if you take the next example, which is 4 and 5, what is the GCD of this? This is 1, 4 and 2, 2. Similarly, this 1 into 5 or 5 into 1. Now, again, GCD is 1. That means what did you observe? The GCD of consecutive numbers, will always be equal to 1. Now we need to construct a matrix whose every row and every column's GCD will be equal to 1. That means, can I say that I can construct a matrix which contains consecutive numbers? And I'll be starting the element from 2 because they mentioned that all the matrix elements should be in the range of 2 to mat of I comma j should be in the range of 2 to 10 power 9. Okay, so I'll be constructing a matrix like this which contains the consecutive numbers. Okay, now tell me what is the GCD of this row? Can I say that GCD of this row will be 1? As we saw the examples over here. Okay, now GCD of the first row is 1. Now similarly, I need to construct a column whose GCD will be 1. That means the column elements should be also consecutive elements. Similarly here, how can I get the consecutive elements? Starting from 3, 4, 5, 6. Next, here this column needs to be GCD 1. So even here I can get it as consecutive numbers and so on, right? So this is how we need to construct a matrix. Once we got this matrix, obviously the GCD of this matrix will be 1. How? By looking at the fact that we have saw previously, GCD of consecutive numbers will be always 1. Now we need to construct this matrix and we need to simply print this matrix. Okay, how will you construct this matrix? First, we can fill the entire 0th row with the consecutive number starting from 2 to some value. Okay, 2 to some value. Once we got the entire 0th row, we can fill the 0th column and the rest other elements of the matrix. So now let's see how to fill this matrix. So initially you'll be filling the 0th row with the consecutive numbers, which is 2, 3, 4, 5. Okay, now how can you get 3 over here? We can use these values. We can use these values. Let's say if this is I and j, let's say the index of this is, let's construct a matrix like this. This is 0th row, 0th column, first column, second column, third column. Then first row, second row, and third row. So obviously the value of this index will be 0 comma 0. This will be 0 comma 1, 0 comma 2, 0 comma 3. Okay. Now how can we fill the value over here, which is 1 comma 0? How can I fill 1 comma 0? So now we are focusing on filling the value, which is a of or mat of 1 comma 0, mat of 1 comma 0. Now can I simply say that here the value will be 3? That means 2 plus 1. Now how, if you are here, how can you access the element of the previous row? Can I say that the value of the index over here will be mat of 0 comma 0? That's it. How can I convert this into a general formula? If we need to fill a matrix of ij, how can we fill? We can simply access the previous row element. That means I minus 1 j plus 1. That's it. This is how you fill the matrix. Okay, so now let's write a code to populate the matrix and we'll print the matrix. So let's start writing code for this. First, we'll be taking the value of test cases. Then we'll be taking the input for size of the matrix. So n command cl and once we got the size of the matrix, we'll be declaring a matrix of size n cross n. So mat of n. Then what did we decided to do? We need to first fill the values of the 0th row. So for that, we'll be taking one variable. Let's say x will be starting from 2. Why from 2? Because they mentioned that it should be starting from 2. That means the matrix elements should not be 1. Okay, now so we'll be starting iterating from 0 I less than. Now we need to fill the 0th row, right? That means how many elements will be there in 0th row? Equal to number of columns. So we'll be iterating from 0 to m I plus plus. Now we are iterating on 0th row. That means row will be constant and I will be moving every time, and it will be x plus plus. Simply I can do x plus plus. Next. Now we have successfully filled the 0th row. Now how can I fill the entire matrix? We need to start filling the matrix from the first row. So I start from 1. I goes till how many rows do we have? N rows. I plus plus. Then we'll be taking j loop, starts from 0, which needs to be iterating on the column. So j starts from 0, j less than m, j plus plus. Okay, so mat of, what is a formula that we have came up with? Mat of ij is equal to mat of I minus 1, previous row, same column, plus 1. That's it. Now after filling or after generating the matrix, what I'll do, I'll simply print the matrix. So I starts from 0, I less than n, I plus plus, and we'll be iterating on the columns. J starts from 0, j less than m, j plus plus. See out, you know how to print a matrix, so see out mat of ij. Let's see, do we have space in between? Yes. So space and new line every time after printing the each row. That's it. Let's run this and see, are we getting the required output or not. Okay, we got the output. Let's submit this and see. And yeah, we are missing one more point over here where we need to print the matrix in a new line for every test case. So we'll be adding one more new line over here. Let's submit this and see, will it work or not. Taking time. Done. Okay, so this is all about the third problem. moving to the next problem, which is GCD to 1 harder version. We already saw how to solve this in the easy version. Coming to this hard version of the problem, the only difference between the first variation and this variation will be, in this you need to generate a matrix whose GCD of each and every row and each and every column will be equal to 1. Also, there is one more extra condition over here, that the matrix that you have generated should be minimized sum of the entire matrix. Okay, so apart from that, the entire problem statement is set. We need to construct a matrix A of size n cross m such that GCD of every row and every column is 1. Also, one more extra step we need to do over here is we need to minimize the sum in the matrix. And as usual, the matrix elements should be greater than or equal to 2. Now coming to the input format is same. We'll be having n rows and m columns. Output format will be printing the matrix of size n cross m. Okay, so yeah, if you observe, this is your sample input and output. The first matrix is a square matrix. The next matrix is a rectangular matrix. So this says you that every time we won't be given a square matrix. Now keep this in mind. Okay, now let's understand the problem statement clearly. Now let's understand the problem statement. Let's say you have a matrix of size n cross m. Let's say there are n rows in your matrix and m columns in your matrix. Now we have took a matrix of size 3 cross 3, so the value of n and m will be 3. Now we need to generate a matrix such that GCD of every row will be equal to 1 and GCD of every column will be equal to 1, as well as we need to minimize the sum of matrix. Okay, so these are the two things that we need to keep in consideration while constructing the matrix. Now if you think in a general way, how can I get GCD of every row as 1? Simply I can place all ones in all the rows, similarly all ones in all the columns. Now what is the GCD of this row? 1. GCD of this is 1, GCD of this is 1. Similarly, GCD of this column is 1, GCD of this column is 1, GCD of this column is 1. And the value of sum we got is equal to 9. Okay, which is pretty simple. But can we generate a matrix like this with all ones? No. Why? Because they told you in a problem statement that all the matrix elements, which is mat of ij, should be greater than or equal to 2, should be less than or equal to 10 power 9. That means we cannot consider 1 in the matrix. So clearly this is not a valid matrix. So now you might be thinking that we'll be taking all 2's in the matrix. Let's say if I take all 2's in my matrix, what is the GCD of each row and each column? GCD of this rows will be 2, GCD of this column will be 2. But this is not a valid matrix. Anyhow, we are following this constraint, but we are not generating a matrix whose rows and columns are equal to 1, right? So this is also not a valid matrix. Okay, now we have all 2's. How can I get GCD of this row as 1? Let's say we have all 2's over here. How can I get GCD of this row as 1? If I say that if we have at least 1, 3 in this row, now tell me what is the GCD of this row is equal to 1, right? Now, similarly, even here there should be at least 1, 3 in this row and at least 1, 3 in this column. Okay, so I'll be adding 1, 3 over here and one more 3 over here. Now, what is the GCD of every row? Is 1. GCD of every row is 1. Okay, what about GCD of this column? 3, which is not satisfying this condition again. That means even my every column should also have some different elements, right? Now, how can we do that? Here we should convert this to 2 again and this to 3, right? Now, instead of doing all these things, can I include 3's in all my diagonal elements? That means if I include 3's in my diagonal elements, what will happen? Can we get at least 1, 3 in each row and column? Okay, let's see, are we getting it or not? Okay, so now tell me, what is a GCD of this row? The first zeroth row is 1. GCD of first row is 1. GCD of second row is 1. What about GCD of the first column? 1. GCD of second column, zeroth column will consider. So GCD of zeroth column is 1. GCD of first column is 1, and GCD of second column is also 1. And we have constructed a matrix which is a valid matrix and which is also following this condition. But why do we took only 2 and 3? Why not some elements which are greater than 2 or 3? Okay, instead of 3, let's say we take 4. Okay, before taking 4, let's calculate what is the sum of this matrix. So what is the sum of this matrix? Okay, it will be 6 from here, 6 from here, so 12. 12 plus 9. What is the value of sum? 21. So the sum of this matrix is 21. Let's say instead of 3, I take 4 over here. Now what is the value of 22, which is greater than this? What do we need to do? We need to minimize the sum of matrix. So that is the reason why we took only 3's and 2's in my matrix. Okay, so what will I do? What is the observation that we have came up over here? The first step is we need to fill all the diagonal cells with 3. Okay, and all other cells will be 2. Now we need to handle one more case over here where we took a square matrix over here. Now, as we saw in input, sample input, there will be also a rectangular matrix as well. That means the value of m will not be 3. This time it will be 4. Now, what will you fill over here? What will you fill in this extra added column? If you fill all 2's, let's see what will happen. If I fill all 2's over here, what is the GCD of this row? GCD of this row is 1, GCD of this row is 1, GCD of this row is also 1. But what is the GCD of this column? 1. GCD of this column is 1, GCD of this column is 1, GCD of this column is 2, which is again not following the condition. That means even in this column, we should have at least 1, 3 anywhere. Anywhere. Now, is it following the conditions that we need to follow? Yes. That means we need to also handle a case where the value of m is greater than m. Similarly, the value of n will be greater than m sometimes in some test cases. Right. If this is the case, we know how to handle it. We'll be iterating on the extra columns that have been there and we'll be filling at least one of the cell as 3. Right. Here we need to iterate on the column, extra columns, and here we need to iterate on what? Extra rows, and we'll be filling at least one cell in all the leftover rows with 3. Okay, we saw a case for this. Let's see a case for this as well. Now let's say we have this matrix that we have constructed for a square matrix. Okay, as of now it is following the all 3 conditions given in the problem statement. Now let's see for this case. So let's construct a matrix for this. As of now, this is the matrix that we have. Now we'll be having let's say 4 rows or 5 rows and 3 columns. So the value of n is 5 now, the value of m is 3 now. That means we'll be having 2 more rows extra in the matrix. Okay, this is 1 row added and this is 1 row, and there will be 3 columns. Now what you need to do in this row? You need to fill with 2's and 3's. That means you should have at least 1 3, and all other 2's. Even in this, you should have at least 1 3 and all other 2's. Simple. Okay, you can place this 3 anywhere, but there should be at least 1 3 in each of the row. So let's say I'll be placing 3 over here. Now, what is the GCD of this row? 1. GCD of this row is 1. GCD of this column is 1, and GCD of all other columns is also 1. Okay, so what is the overall logic that we have came up with? First thing is we'll be filling all the diagonal cells with 3. Now we know how to access all the diagonal elements. Next, if the value of m is greater than n, what will you do? We will fill extra columns with at least month with 1 3. Similarly, if the value of n is greater than m, what will you do? You will fill extra rows with 1 3. That's it. And after generating the matrix, you will be printing the matrix. So this is the overall observation that we have made over. Now let's start solving this problem. So the first thing we need to take input is number of test cases. Okay, then we'll be taking the number of rows and number of columns, which is n and m. Okay, after taking the input, what we need to do? We need to declare a matrix of size n cross n. Then what I'll be doing is I'll be simply converting all the values of matrices to 0. So first I'll be iterating on the matrix. Then what I'll be doing is I less than m and I. Okay, not I. Let's take some different variable. J equal to 0, j less than m, j plus plus. Okay, now I'll be filling all the matrix elements with zeros first. Okay, after filling all elements to zeros, what I'll be doing? I'll be traversing diagonally and filling all the diagonal elements with 3. So let's take a for loop where I starts from 0, I less than n, I plus plus. Now, it's not required to take 2 for loops to fill diagonal elements, because we know in diagonal elements the index values will be same. So either it will be 0 0, 1 1, 2 2, 3 3, and so on. So simply what I'll do is I'll be taking mat of I comma I is equal to, we need to fill it with 3. Okay, next. What we need to check? We need to check if the value of n is greater than m. Let's check m is greater than m. Now, in this case, what we need to do? We need to iterate on the extra columns. So for int I will be starting from which point? If m is greater than n, can I say that till nth column we have filled all the columns or all the diagonal elements with 3? So we'll be starting from nth column, and I should go till m columns I plus plus. And mat of, now we need to keep the row as constant. That means 0 comma I. Now this value will be equal to 3. Similarly, I'll be doing it for columns as well. Sorry, rows as well. That means if the value of m is less than n, now we need to start iterating from the mth row. We should go till nth column. Now this time the column will remain same. Let's say we are filling 3's in the 0th column, and rows should be changed to 3. That's it. Next, what I need to do? We need to iterate on the entire matrix, and we need to convert all zeros into 2's if it is not equal to 3. Simple. So for int I starts from 0, I less than n, I plus plus. Next, j starts from 0, j less than m, j plus plus. Now if mat of ij, if it is not equal to 3, we should be filling their values with 2. Okay, now let's print the matrix. We have successfully generated a matrix which follows all the conditions given in the problem statement, and now let's print the matrix. So I starts from 0, I less than n, I plus plus. For int j starts from 0, j less than m, j plus plus. Now you know how to print a matrix, so see out mat of ij, a space in between, and every new line for every row. So see out, and that's it. Let's see, are we missing anything? So let's see, are we getting the expected output or not? Okay, so we got some similar output, which is a valid matrix. Now let's submit and see what are we getting. Now we got a runtime error over here. Now the reason for this runtime error is, let's say we have a matrix like this 1 2 3, then 2 3 1, then 2 1 3, and okay, let's say that we have this matrix as an input. Okay, now what is the value of n here? The value of n is 6 and the value of m is 3. Okay, if you observe in this for loop, we are iterating from 0 to n minus 1. That means we are iterating from 0 to 5. So the last cell that we are accessing here is matter of 5 5. Do we have a cell of matter of 5 comma 5 in this matrix? No. The last diagonal element that we are going to access is mat of 2 2. That's it. This is the last diagonal element that we can access, right? Now how can we handle this case in this for loop? Simply we need to iterate till minimum of n comma m. So minimum of n comma m. Okay, let's run this now. Before that, let me comment on this. Now let's run this code and check, are we getting the expected output or not? Okay, we got the expected output now. So let's submit this and check, are we getting the correct answer or not? Done. We got the correct answer. So yeah, this will be your code for the fourth problem. So that's it from my side. I hope you learned something new from this video, and make sure to like and share and subscribe to this YouTube channel so that you'll never miss an update. Bye. Thank you everyone.